Hi, welcome to my video on the composition of trig functions number 1. Let's recall the composition of functions. F of x equals 2x plus 1. The g of x equals 3x minus 4. Let's look at f of the g of x. So that's the f. The g of x is 3x minus 4. So we replace the g of x with 3x minus 4. Now we're going to take 3x minus 4 and put it in the place of x here. So that's 2, bracket. The x is becoming 3x minus 4 plus 1. Simplify it. 6x minus 8 plus 1. We get a 6x minus 7. Now what about the g of the f of x? So the f of x is 2x plus 1. So we put 2x plus 1 in the place of f of x. Now we take 2x plus 1 and put it in the x in g. So we're putting it here. So we're putting it right here. So that's 3 bracket 2x plus 1. And this composition of functions was done in the Algebra 2 on sinusoidal functions, composition, set per inverses. Now, sorry, but I just deviated a bit there. So 3 times 2x is 6x plus 3 minus 4. So that's 6x minus 1. So you do the composition of the functions differently, you get different numbers, except if they're the inverse of each other, then the f of g of x and the g of f of x will be the same answer. Number 2, let's look at the trig. The f of x is cos theta, or sorry, the f of theta is cos theta, and the g of theta is arc sine of theta. So that's f. So the g of theta is right here, so that's arc sine theta. Now we take the arc sine theta and put it in place of theta here. So that goes right here. So that's cos of arc sine theta. Again, doing the composition. So let's do some examples of the composition. F of x equals, f of theta equals sine theta. The g of theta is sine inverse of sine of 1/2. Find the value of the f of the g of theta. So that's the g of theta is sine negative 1 of the 1/2. And now we take put this in the place of theta here. So that's the sine. And theta is here. So it's sine to the negative 1 of the 1/2. So there again, composition. But we want to find the value of that. Now to find the value of that, I look at it this way. I'm looking at the arc sine of 1/2. So arc sine, we discussed that in the previous. Sine is sine, cosecant, and tan. They all go together. So they're all, when you do inverses, you're looking at the angle from negative 90, 0 to a 90. And since this is positive, this is negative here, and this is positive here. So it's in the first quadrant and the fourth quadrant. Because it's a half, then it lies here. So that means that we're in, because it's positive, a half, we're in quadrant 1. So we draw that in quadrant 1, perpendicular to the x-axis. Sine is opposite over hypotenuse, so it's 1 over 2. So this is 1, 2. This is a root 3 because it's a special right triangle. Opposite 1 is a 30. So that's a 30-degree angle there. So that means that the inverse of a half is 30-degree angle. Again, you're in the first quadrant, so the rotation is 30. And Same angle. So what's the sine of 30? Sine of 30 is opposite over hypotenuse. So it's 1/2. Opposite is 1 over 2. So you get the same answer. That doesn't happen all the time. Now, let's do a couple of extra. Find the value of each. The tan, and inside composite function, we have cos to the -1 of a negative root 2 over 2. So we have cos, and again, let's look at cos goes with secant, goes with cot. Sine, cosecant, and tan go together for -90 to a 90. So these three go together from 0 to a 90 to a 180. And from 0 to 90, it's positive. From 90 to 180, we have a negative. And since this is a negative number and is root 2 over 2, so we have a negative number. So we are in from 90 to 180. 90 to 180 is in quadrant 2, perpendicular. So what angle? What angle gives me a negative root 2 over 2, root 2 over 2? That's the 45. Because if you got a 45 right triangle, you have a 1, 1 root 2. This is positive, this is negative. So the cos is the adjacent over hypotenuse, so -1 over root 2 multiplied by root 2 over root 2 is negative root 2 over 2. So that's a 45-degree angle. So that's the tan of the 45-degree angle. But the rotation has to be between 90 and 180. So the rotation for that is 180 minus the reference angle. So it's a 135. So that's the tan of 135. And 135 is this angle here. So the tan is opposite over adjacent. So the opposite is 1 over the adjacent, which is -1. So the tan of 135 is -1. Okay, let's try another one. Again, you have to know where they're restricted at. So that's why I did the previous video. So here we go with another one. Find the value. Cos of the inverse cosecant of 2. Well, I got the inverse of cosecant of 2, so that means the reciprocal of cosecant is sine. Reciprocal of 2 is 1/2. So sine to the -1 of 1/2. Let's see where we are. Let's have a look. Let's see. Sine. This is positive. So this is cosecant. A cosecant goes with sine and goes with tan. So that means we're talking about the angles between -90 to 90. So negative between 0 and -90, and positive between 0 and 90. This is a positive number, so we're in this quadrant right here. And sine is related to the 1/2, so sine is opposite in relation to the reference angle, opposite over hypotenuse. So that's a root 3. So if this is opposite over hypotenuse, that means this angle has to be a 30. And because you're in, again, because you're in the first quadrant, this angle, this inverse here is a 30-degree angle. Now we have to look at the cos of 30. Cos is adjacent over hypotenuse. Adjacent over hypotenuse. So in relation to this angle, 30-degree angle, adjacent is root 3 over hypotenuse is 2. So there's some examples of working out the inverse along with the normal function. That's one video. There's some more to come. And if you like my video, click on the like button, click on the subscribe button. If you wish, visit my math website, www.mathfullyexplained.com, to find more information about me, my video, and the content on my YouTube channel called Math Fully Explained, just one word. Thank you for viewing my video. Hope the video helped you. Bye-bye.